In this fictional experiment, we will test whether a six-sided die is a fair one. To do so, we record the number of times each phase appeared when we had rolled these dice and create a frequency table. For example, the phase showing 1 was observed 46 times and the phase showing 2 was observed 35 times, and so on. Next, we calculate the total number of observed rolls using the Excel function sum. Now we need to determine the expected frequencies. Since our null hypothesis states that the die is fair, our outcomes should be equally likely. The expected frequency for each phase is calculated by dividing the total number of rolls by the number of possible outcomes, 6 in our case. The sum of expected frequencies equals the sum of observed frequencies. For each phase, we compute the square of the difference between the observed and expected frequencies, then divide the result by expected frequency. The chi-square statistic is the sum of these values. The degree of freedom are calculated by subtracting 1 from the number of possible outcomes. In this case, 6 possible outcomes minus 1 give 5 degree of freedom. To determine if the die is fair, we calculate the p-value corresponding to our calculated chi-square statistic using the appropriate Excel function with 5 degree of freedom. If the p-value is less than significance level, in our case 0.05, we reject the null hypothesis and conclude that the die is biased. If the p-value is greater than 0.05, we fail to reject null hypothesis, meaning there is no significant evidence to suggest the die is unfair. This is not what we observe in our case. Calculated p-value is lower than 0.001, so if we had chosen lower significance level, we would still be allowed to reject null hypothesis. Another possible approach is to compare our calculated chi-square statistic to critical value from the chi-square distribution table at the chosen significance level. Again, in our case, the level of 0.05. If the calculated chi-square statistics exceeds their critical value, we reject the null hypothesis and conclude that the die is biased. Otherwise, we fail to reject null hypothesis. In our case, we do reject null hypothesis.